Welcome back to our deep dive on Matter. We're covering it from all angles today, and right now we're going to be talking with Larry Olivas.
Hi, Bill.
Hi. He's an expert in radio coexistence, right?
Okay.
And I know a little something about that, but we'll ask Larry to walk us through it in some detail. Just for starters, make sure I've got this all right. Matter, what it does is defragment the smart home wireless connectivity infrastructure. And it standardizes on 3 different radios to do that. Wi-Fi, Thread, and Bluetooth, but Bluetooth is really only used for commissioning, for setting up the network to begin with. It's not used for data communication. And these radios all have one thing in common, and that's the frequency band that they use, which is everybody's favorite ISM band, the 2.4 gigahertz part of the spectrum.
Yeah.
And a little story about that. It's really one of the few frequency bands that's the same worldwide. And the reason for that surprises some folks. 2.4 got started with a tube device that was used in microwave ovens called the magnetron. And to this very day, all the microwave ovens around you operate at 2.4 gigahertz. And so there's this band of frequencies that nobody could use because all the microwave ovens were there. And so the FCC and other regulatory agencies kind of got together and decided how to standardize that around the world somehow. And to this very day, that's why we have free use of that band of frequencies, and that's why Thread and ZigBee and Bluetooth and Wi-Fi, all of this stuff uses that band of frequencies. And the problem is, well, I'll let Larry tell us what the problems are, but you've got multiple radios using the same antenna and the same frequency bands simultaneously.
Right.
So that's got to create some problems, right?
It does. I mean, one of the things when we looked at Matter, one of the things that's very powerful about Matter is, as you said, it uses the same, the fundamental technologies themselves, they left intact. Wi-Fi, Bluetooth, and 15.4. But there is, the 2.4 gigahertz frequency, which causes some conflict when you're talking about 15.4 and Bluetooth and ZigBee. And so ultimately what we're trying to do is making this overall problem simplified for our customers, right? So when we talk about the various radio technologies, by implementing those technologies into a single radio or to a single device, it allows us to simplify that overall design. Now, 2.4 is problematic, mainly because, as you said, all 3 radio technologies utilize it. And as smart homes continue to expand, an explosion of regards to the actual devices in the home, the more congestion you have, right? The more congestion you're going to have, the lack of performance, the longer the latency, and things of that nature. So it really requires some expertise around how do we manage the coexistence of those particular frequencies to make them optimally operate within the home.
Could you drill down to the next level of detail on that, like specifically in the design of a radio? What is it that you have to be careful of if you want these radios to coexist? What problems does it cause, and how do you go about addressing that?
Well, so the problem it causes, again, you want to have, it really is about how do you manage the optimization of the software stack, right? How do you manage the overall data stream in that radio configuration?
So if you don't want one radio to be transmitting at the same time the other one is receiving something critical, right? Because the receivers just don't have that much selectivity.
Right,
okay.
Right. And so we spend a lot of time really looking at how do we optimize the overall performance of the stack by optimizing the antenna, optimizing the arbitrator, and we allow kind of both the internal mechanism as well as the external capabilities of an overall radio. So we can adapt to legacy ZigBee solutions through an external radio functionality. But we have a hardware arbitrator that manages all of that activity within the particular device of the tri-radio.
But the tri-radio solution would work, I guess, if you wanted to use it strictly for ZigBee and not Matter, right? You would just simply use the 15.4 radio as a ZigBee radio in that case. But we're here to talk about Matter, so let's not complicate it with ZigBee cohabitation on that transmitter. So The three Matter radios provide two different functions, right? Could you break that down and like which radio does what?
So we typically have one radio that manages the Wi-Fi functionality, and that can operate in about 2.4 or 5 gigahertz operation. We have a separate radio that manages basically the Bluetooth and 15.4, so ZigBee or Thread. And again, that configuration can change. You can go to single antenna operation where you put a switch, or you can go to a 3 antenna configuration where you have a separate external ZigBee solution as part of the offering.
So do you have to test this? Like if I'm an equipment manufacturer, I'm a CE guy, like the folks here at this CES trade show. If I wanted to make a multi-radio Thread device, is there any certification or testing that has to take place to get a logo or to get some kind of certificate or something that says that?
Yeah, it's a very good question, right? So all of these radio technologies have their own certification body, right? The WFA, the Bluetooth SIG, and so on. You have to get this nice certification. When it comes to coexistence, you don't. There is no certification body that actually gives you this certification. That being said, there's a significant amount of testing that goes into this, not only internally, but as we go through the particular customer implementation or their particular use case, there's a lot of testing with regards to coexistence. This is really how you differentiate yourself in the market. Coexistence for us, and why we spend so much time on coexistence, is really where we see the value in our overall delivery to our customers. That's where they see the simultaneous operation of these radios is key for their optimization.
Yeah, and that's really good news for your customers, because I'm sure they don't all have the deep RF expertise that it takes to, they don't all have that, some might, but most of them probably do not have the deep RF expertise to do this.
Yeah, what we try to do with our Tri-Radio family of products is that we've really focused on integration of the overall functionality of the radio. So we have obviously the Wi-Fi, Bluetooth, and 15.4 architectures in the hardware, but we also integrate the RF front end. So the entire RF front end functionality is integrated in the device. That's there for two reasons. One is obviously it saves on the overall cost of the solution, but more importantly, it reduces the complexity for our customers. They now have to only worry about antenna configurations and placements and things of that nature, and we help them through that process as well.
Yeah, plus the external component count goes to practically zero.
Exactly.
I mean, it's just a chip. It's
exactly.
just really amazing technology. Does Tri-Radio make it easier? I mean, used to you had multiple radios, right? Multiple chips. Again, with the same antenna sharing and switching problems, but they were in separate chips. Putting everything in one package, in one silicon package, does that make it easier or harder to do coexistence?
It definitely makes it easier. There's a couple of reasons for that. One is you can actually define your software stacks from the beginning with coexistence in mind, right? So you have it all in one place.
Yeah, you're in control of the whole stack.
You're in control of the whole stack, right? So you can manage the prioritization of the packet, you can manage the prioritization of the particular use case, right? So in some cases you want a carbon monoxide sensor to have priority over some other function, right? So you can manage that within the use case itself. But that doesn't mean that you can have an external configuration of coax. We still, as I said, in our devices, we do allow for external modems, a 5G modem or additional ZigBee device attached to the particular device. So we can handle the external coexistence, but you do lose GPIO, you have to worry about different package implementations. So the overall cost of the solution becomes more complex.
Right. Okay. That's a pretty good story. Especially from the standpoint of a device maker, the whole idea behind Thread is to make it possible to build pretty much identical devices that work with any ecosystem and with any other set of similar devices, right? So the whole idea behind Matter is to make that all as simple and interoperable as possible. And so having the coexistence problem kind of factored out in as close to the silicon as possible makes life a lot easier for CE companies, because they don't need to worry about that. One less thing for them to have to engineer.
Yeah, you're exactly right. So when you talk about Matter, the whole idea of Matter is that if you really look at it at the 10,000 foot level, the intent of Matter is to make it easy for the consumers. Our job as NXP is to make it easy for the developers. So we want to make it as simplistic as possible for our customers to develop as many products as possible to get into the market to address the Matter space.
Yeah, I get it. I guess one final question. I think I know the answer, but let's say you have multiple Matter devices that are not on the same platform, but are packaged in next to one another. Like for example, on the wall, maybe a row of 3 or 4 light switches that are remote controlled using Matter. So then you have 4 Matter radios right next to each other. Is that a coexistence concern?
No, I mean, ultimately we have configured the situation so it's actually isolated to the device. And so the controller itself can manage the functionality of all 3 of those or 4 of those switches simultaneously without any issue.
And without any coordination between the products. Okay. So they just happen to be located next to each other, and you just live with whatever receiver desensitization is going on or something like that. Yeah. It's all just part of the...
Yes, it's similar to any congestion device that you have, right?
Yeah, so exactly, like a bunch of cell phones right next to each other.
Exactly, yeah.
Okay. All right. Anything else that you'd like to bring up?
No, I think for us, from an NXP perspective, we do believe that coexistence is a very necessary element of a tri-radio solution.
Oh, absolutely.
And so we spend a significant amount of time making sure that this is something that customers can feel at ease, that we've taken the time and the effort to make sure that the coexistence solutions is solid for them.
That's awesome. Really good stuff. Well, thanks, Larry. Really appreciate that.
Yep.
3 radios on the same band. Coexistence is a big deal for Matter, and it's great to see that NXP has it covered. So please join us for other videos as we explore the technical details of Matter with industry experts like Larry.